The dot product of two vectors A and B is equal to the product of the magnitude of the two vectors and cosine of the angle between the two vectors. The result of a dot product is always a scalar. Now, let's see some properties of the dot product of vectors. 1. The dot product of vectors is always a scalar quantity. 2. The dot product is commutative. Consider the two vectors A and B inclined as shown. Theta is the angle between the two vectors. The component of one vector in the direction of the other is called the projection of the vector on the other vector and is denoted by the product of the magnitude of the vector and the cosine of the angle between them. Hence, we see that B cos theta is the projection of vector B on vector A. So, the dot product of vectors A and B can be written as A into B cos theta, which is equal to AB cos theta. Let this be equation 1. Similarly, we see that A cos theta is the projection of vector A on vector B. So, the dot product of vectors A and B can be written as B into A cos theta, which is equal to AB cos theta. Let this be equation 2. From equations 1 and 2, we see that A dot B is equal to B dot A, which is equal to AB cos theta. Thus, the dot product of two vectors is commutative. The dot product obeys the distributive law. So, A dot B plus C is equal to A dot B plus A dot C. All dot products obey the rule M times A dot N times B is equal to Mn times A dot B, where M and N are just constants. Consider the unit vectors along the Cartesian coordinate axis I, J, and K. The angle between any two vectors in the same direction is 0. Thus, when the two vectors are parallel and in the same direction, then the magnitude of their dot products is maximum, as cos 0 degrees is equal to 1. Thus, we get I dot I equals 1, as shown. Similarly, we get J dot J and K dot K equal to 1 as shown. The angle between any two mutually perpendicular directions, that is, between I and J, or J and K, or K and I, is 90 degrees. And cos 90 degrees is 0. So, I dot J is equal to 0. J dot K is equal to 0. And K dot I is equal to 0. How can we find the dot product of a vector expressed in terms of its components along coordinate axis? If two vectors A and B are expressed in terms of their components along coordinate axis AX, AY, AZ, BX, BY, and BZ respectively, then A dot B is equal to AXI plus AYJ plus AZK dot BXI plus BYJ plus BZK, which is equal to AXI dot BXI plus BYJ plus BZK plus AYJ dot BXI plus BYJ plus BZK plus AZK dot BXI plus BYJ plus BZK equal to AXI dot BXI plus AXI dot BYJ plus AXI dot BZK plus AYJ dot BXI plus AYJ dot BYJ plus AYJ dot BZK plus AZK dot BXI plus AZK dot BYJ plus AZK dot BZK, which is equal to AXBX into I dot I plus AXBY into I dot J plus AXBZ into I dot K plus AYBX into J dot I plus AYBY into J dot J plus AYBZ into J dot K plus AZBX into K dot I plus AZBY into K dot J plus AZBZ into K dot K. Substituting the values of I dot I, J dot J and K dot K as 1 and the values of I dot J, I dot K, J dot I, J dot K, K dot I and K dot J as 0 and simplifying, we get A dot B is equal to AXBX plus AYBY plus AZBZ. It is also equal to BXAX plus BYAY plus BZAZ, which is equal to B dot A. As the dot product is commutative, A dot B equals B dot A.